One more time again, welcome to ICE Education, the only education that matters. I have a good intro, eh? Okay. Speed and energy fluctuation. You have a crank pin. What else do you have? You have work, you have power. Okay, I'm gonna keep it short for you, ne? In this chapter here, it will be all about solving the energy of fluctuation. What will be changing here? You see there are different formulas, right? Power, whatever. Don't worry, you will see as we solve it. You have what you need is the energy of fluctuation. Sometimes they can ask you to solve for coefficient of fluctuation speed. But what is importantly, the first thing to do is to get the EF. It is what they call energy of fluctuation. So what we'll be doing in this chapter here, we'll be finding EF for all the cases. You have 3 cases and some of them just come. You have cases where you have to plot by reading. You have a case where you have to, you are given torque moment. Let me just show you what I'm talking about. All this will be applied. This is the first case, ne?
Okay.
The M is simply to get for EF, whatever case that you have. After this, what do you get? EF. Do you see it? From there you answer the question. Let me show you another case. This is example 2. Example 2, whatever you do there after solving, at the end of the day, what you get first is what? EF. Do you see it again?
Okay.
Example 3, whatever the case may be, at the end of the day, again, what you still get is what? Your energy of fluctuation. If you want to solve for whatever is here, what you need is energy of fluctuation EF, which is this one. So you've got 3 cases under this topic, and 3 cases differs from formula and what to do and what, so you'll see as we do it. Hey, this guy just clear circuit board. Yeah. So can we start with example 1 so that we can do something? Huh?
Okay.
How have you been, Angela?
Well, I think so. But I went home, so yeah, I'm fine. I'm happy.
Hey, I see people love home ne, when it's holiday like this. What is home? Home is nice, ne?
Yeah, very nice.
Okay. Okay, let's start then. I'm glad that you are fine. That's what is important here. Yeah, that's what matters anyway. In case 1, this is the case where you are given different type of energy and you need to solve for EF. Let's look at example 2.1. You see this formula that you see here, it goes with the type of problem that you are solving. So I'll be using them as we are moving, right?
Okay.
Don't worry about what you see. As we move, I'll be using formula and introducing what needs to be done. Okay, let's at least start with example 1. It says that the turning moment curve of one cycle machine driven by a constant torque motor shows the following intercepted areas below and above the mean lane torque. This is it. And we are given a scale 1 millimeter is equal to 2 Newton meter, and the scale on the crank angle is 1 millimeter equal to 6 degrees. The mean speed of rotation is 360 minute, and the coefficient of fluctuation speed is this. Calculate the maximum fluctuation energy as well as the moment of inertia. This is what it is important. Before you solve any question in this topic, you need to be able to solve for EF.
Okay.
It's a must. So in this case, how do we deal with it? Let me open my textbook because I have the hard copy. I don't know why. Am I suffering like I do not have the book? Even though I cry, it doesn't mean I am weakling. Let me check if this video is complete. Actual centrifugal. It's not bad. 109 views. Not bad. Not bad. ICE education. Okay, let's get back to work. Now, what is happening here? On example 1, you are given different type of energy. So what does it mean? You need to plot this on a graph. Yeah, let me use the technology. Am I the only one, or this 90 looks Q?
It's not straight.
Hey, I thought maybe it's me. Okay, this is just what's happening. You've got your unit. This one is the torque in millimeter. And this one is theta here, also in millimeter. I feel like eating some McDonald's. Okay, now what is happening? Do you see the unit of this torque here and this theta here? What are the units?
Millimeter.
Normally, what is the unit of torque?
Newton's
Newton's meter. Newton's per meter, ne? Unit of theta, in terms of machine, theta here is work in radian. So, if you read under this problem here, where is it? We are given a scale. The scale is simply for us to help us to convert, because we cannot have energy in millimeters. Do you see what's happening?
Yeah.
You are given 1 millimeter to be equal to 2 Newton meter. We are also given 1 millimeter to be equal to 6 degrees. My goodness. Okay, let's start. You see, if you look at your PDF there, you see you have different energy fluctuation there, right? You have minus 10. You always start at E, which is the reference point. Do you see it?
Yeah.
Now, okay, it's E is the reference point, but they call this one point A here. This point A. Now, what is happening? It is minus 10. You can amply see A here show a minus 10 going down. This is the case when you are given different energy fluctuation. Do you see it?
Yeah.
Are you with me? If you look at on the figure, on the problem, where is it again? You are given minus 10 plus this. Do you see what's happening?
Yeah.
Now I'm just plotting it in the graph. So if I am on the graph here, how will minus 10 go? It will go down. Do you see it?
Yeah.
So it will go until it is here. Now, what is the next point? If you look at the next point, I think it is positive 60.
Yeah.
So you will go up positive 60. So it means you can simply draw a line, a curve a bit bigger to show that positive 60 is a bit bigger, right?
Yeah.
What is the following one? Negative 40. So again, you know negative 40 is bigger than negative 20. You just show a curve like this. I usually like writing. I like to write that this is negative 10. This is positive 60, so that you see what you are doing. This is negative 40. Now you go up positive 50. Do you see it?
Yeah.
You go down negative 80. Negative 80 should be a bit bigger. And then you go up again positive 20 until it ends here. So this is basically how you represent this. You see, you just show, but you don't need, it doesn't have to be as accurate, but you can just show the difference in size, because you know 60 is bigger than 50, so its range has at least to be bigger. Right, do you see it?
Yeah.
Now you can name all the points that are catching the X down here. You have A, B, C, D, E, F, And then we do have a G. Are we together on the first steps, you see?
Yeah.
Now, the second point is to record energy at each point before we solve the M. Remember, the main objective is to get for EF. In this case, this is how we solve it. Now, you start point by point. Do you agree that at point A, you've got E only? Or the origin. So at point B, what do you have? It is E minus what you see here. Is it minus 10, right?
Yeah.
You just go like that. E minus 10. At point C, what do you have? You have what you are doing is what you have left plus what you have. Actually, if I want at point C, I will stand on point C here. Do you see?
Yeah.
Now I will take everything that is behind me. What is behind me? It is E minus 10 plus E plus 60. Do you see it?
Yeah.
So it is E minus 10 plus 60. So the answer is E plus 50. I also wish I could go home. Maybe it will make me feel better. I've been in South Africa for long now.
How many years?
In May it's gonna be 8 years.
Yeah.
I grew up here.
Okay.
So in D, what's gonna happen in D? You only have what you have here minus 40. Do you see it?
Yeah.
So I think maybe you need a small break here and there from SA. But I love South Africa, yo.
More than you can.
I think so. No, it's not even, I think so, because I've lived all my 20s in South Africa from where I was 18 until now. So that's actually my life.
Yeah.
I was home until I was 18, so there is not much to remember except my childhood. But here, this is where I built a life, relationships, people, Yeah.
Everything.
So at number E, we go E plus 10 plus this 50 that you see here. So for me, South Africa is home, to be honest. It feels like home.
So when you left, you didn't go back home?
No, I've never been. I've never been, to be honest. It's been 8 years I'm here.
Yeah. So you last saw your family 8 years ago?
Imagine. My mom is now getting old.
And you should go home.
Yeah, I need to, this December, I need to take a break from SA and then come back. So F, what is F? F is E plus 60 minus 80. Do you see it? Do you see what I'm doing, right?
Yeah.
Okay, thank you. I'm glad we're on the same page. It's actually faster having a class with you. What is D? This is 20. D is E minus 20 plus 20, which is what? E. Okay, this is what's happening. It starts at E, it also ends at E. So it means that if you are on the last point here, do you see it, right?
Yeah.
And you are not getting E, it means somehow in your calculation here you are making a mistake. The good thing about this chapter, you can actually track your work. Money can't buy you happiness, but I want all the money in the world. Okay, what is next? The aim is to find EF. So how do you find EF, CC, in this category? The way we find EF, it is basically E maximum minus E minimum. Now, it is E max minus E min. Okay, what is E max? E max and delay, it is simply the highest positive value that you see on this point. When you see A, B, C, D, E, where do you have the highest value?
E.
Okay, so we can agree here already that here we're going to have E as the maximum. Now, the minimum, this is a good question. What is the minimum? The minimum is simply, I can say, the lowest value on the negative. Remember, if you have minus 10 and minus 20, which one is bigger?
10.
10 is bigger, ne?
Yeah.
So it means, what is the minimum? The minimum is what? Is 20, right?
Let's do it.
Yeah,
Yeah.
otherwise, I also say when I'm in class, I was telling people, if you are confused between what is minimum, what you can do is you can look for where you have a negative value. Do you see?
Yeah.
Now you look for the highest value. I don't know if it's making sense. You see where you have a negative sign. You have minus 20.
Yeah.
Now you look for the highest value, which is 20. So it means that point should be your minimum.
Okay.
So do you agree with me? It is E and F, right?
Yeah.
So what is E? E, you know it is E plus 60, right? Minus of the formula, what is F?
E minus 20.
So do you agree it's going to be E minus of the formula will give plus 20? Are you with me? I just try to move a little bit faster. There's this minus. Remember, this one is E minus 20. So if you multiply out, you have negative E minus and minus give plus.
Yeah. Okay.
No, let me just do it. Let me not try to skip. It is basically like this. Do you see it?
Yeah.
When you multiply out, you have minus E plus 20. That's basically what I have. Okay, the E and E cancel out. So what do you have? You have 60 plus 80, which is 80. What is the unit here? The unit of this energy here, it is 80 millimeter square. Why is it millimeter square? Because this energy is fluctuating along the torque and theta. But what are the unit of theta and torque? It is what? Millimeter. Do you see it?
Yeah.
But what do you know about energy? What's the unit of energy? What, when we talk about energy, what's the unit of energy? It's joules, right? So that's one of the reasons. In this case also here, you will always have a conversion. It doesn't matter even if it is centimeter, or millimeter. Oh my goodness. Are you with me, Angela?
Yeah.
Okay, next things to do when you do this, because some people during the test, they leave it like this and they get it wrong. You need to convert this. The only way to convert is, remember, you are given a scale. What is you are given a scale? Newton meter times radian gives you joule.
Okay.
So what can we do with these scales? We have millimeter square, right? Can we get millimeter square here? What do you think? If we want to get millimeter square, what do you think we should do? Just try to think.
Oh, I think we should divide by 1,000 squared.
Why 1,000 square?
I get it. It's millimeter squared.
Okay, what's happening? Look at what, if you have newtons times theta in red, it gives you joule. Do you see it?
Yeah.
Now, you have 1 millimeter gives me 2 Newton meter. Do you see it? 1 millimeter gives me 6 degrees. This scale will be given in the problem. It change depending on who's searching the problem, right?
Yeah.
Now, if I want to get millimeter square on this scale here, what do you think I should do?
Oh, okay. You should multiply the
Do you
80
agree?
by 2. Yeah,
If I do 1 times 1, it gives me what?
1.
Millimeter square. Do you agree? So what is millimeter square? It is 2 times what?
8.
Times 6. Do you see?
Oh, okay. We are here. Okay. Yeah, times 6.
But remember, we said it has to be in radian. So it's going to be pi over what? 180. Do you
8.
agree? Now, this one here, it gives you what? Joule. That's what it means. Do you see it? Talk to me, Andy, if you don't see it.
Yeah, I see it.
So what is happening here? Hey, River 2026. So it means on my energy here, where I will be having millimeter square, I will replace the millimeter. I will have 80 times 2 times 6 times pi over 180. Now if I calculate this, I will now get my answer here in joule. I'm pretty sure if you do it, you'll get 16,76. Now you have solved for the energy of fluctuation. This is not the energy of fluctuation. This is it in joule. So if you stop here, because I see some people, they make usually this mistake. They stop here and they start solving the problem with this. And if this is wrong, the rest is wrong. Any question? So what does it mean, Andile? If it is centimeter, this should also be what? Centimeter. The unit doesn't matter. They will give you a scale. Do you see?
Yeah.
I feel like today I worked very hard today. Not that hard, but I did it. Proud of myself. Okay, Andile, now that we get EF, what is next? Next, they said we should find the energy of fluctuation. Do you see it? No. What is next on the problem? They said we'll do the flywheel after, ne? I'm just showing you. They said maximum fluctuation energy. Do you see it, Andile?
Yeah.
As well as the minimum moment of inertia. Okay, there's a formula that I wanted to show you. Like I said, I'll be showing this formula that as we proceed. You have this formula that says that Ks is equal to EF over I W square. Are you with me? Ks is called coefficient of fluctuation speed. Do you see it? That's Ks.
Okay.
So it is called coefficient of fluctuation speed. So when you read this problem, when they say the coefficient, remember they said the mean speed. This is the W. Do you see it? 360 RPM. What are minimum? And the coefficient of speed fluctuation is plus minus 1,5. What is this one? Ks, right?
Okay.
The only reason why Ks is in percentage, the only reason 1 Ks is given plus minus 1,5. Do you know what is the reason, Andile? It is because this energy is fluctuating between two axes. It's catching up, down, up and down. Do you see it?
Okay.
Normally, it simply means if you want to get Ks when it is plus minus, it is 1,5. There is minus of the formula, and there is the minus that come with this minus 1,5, which give us what? 3%. This is your Ks. But remember, you do not have to do this like this. What I've said in class, even with others, if you are doing this type of problem, do you see, Andila?
Yeah.
And they said the Ks is plus minus. You just take this value, you multiply it by 2.
Okay.
You don't have to do this long. Now I'm just explaining to you why is it 3. So it means it is plus minus on the positive side. Do you see? Minus of the formula. It is minus on the negative side. That's what makes it 3 like this. But remember,
Okay.
this thing does not have marks. So if you see a plus minus in this case, just know that it is this thing multiplied by 2.
Okay.
Which is 3. So in this question here, if we are asked to solve moment of inertia, what do we do here? We make I subset of the formula, right? It is EF KS W square. What is EF? Your energy is 16,76. What is KS? KS is the percentage. So you need to get it. It's going to be 0,03. Do you see it, Sissy? Why am I calling it
Yeah.
until times? What is the speed? It is in ref per second, so you need to convert. It is 360 times 2 pi over 60 squared. So if you calculate this, I'm pretty sure you will get your moment of inertia to be what is 0,393 kg meter square. Do you see it, Angela?
Yeah, I see it.
Yeah, so what is the moral of the story? The moral of the story, for the first case, this is how you solve for the energy of fluctuation. And this formula is the most used in this topic. Can we move to case 2? I will explain the flywheel after. That's a different topic.
Okay.
Can we look at example 2, Angela?
Okay.
Eh?
Okay.
It's quick. It's not. It's quick. Hopefully I can finish this in 40 minutes. Evening, sir. I've been. No, I'm not calling you for 50 rand. You see what's the problem with people, Angela? Not the
That's
problem
the
with people.
problem.
No, Mr. Hong is short of 50 rand on the payment. So when I called him, he thought I was calling him for 50 rand. But I was calling
So
him
that's
to
why
join
he
the
didn't
class.
answer.
Yeah, he's making me feel bad, eh? It's fine. So he's telling me that no, the 50 rand I'm getting paid. Yeah, ne? But it's fine. It is what it is. That's why you don't have to conclude for people. You need to ask people what's going on. Because now he's concluding for me that. But anyway, it's my 50 rand. He can give anyway. Okay, can you do example 2.2? They said this is the case when you read and you plot, right?
Okay.
You have to be careful. They said example 2.2, the variation of a crankshaft torque as 4 cylinder petrol engine may be approximate as follow. I need to make sure I finish before half past. But you need to understand. They said increasing, this is the torque and angle, increasing from 300 Newton meter during 45 degrees. Remain constant during the next 45. Decreasing uniformly to 0 during the next 180. Now they said the cycle is repeated after each revolution. The average speed is 600 R min. Question 1, they say calculate the power developed by the engine. Question 2, they said suppose that the engine is driven by the machine. Calculate the mass moment of inertia. Now, do you see the variation speed, which is the coefficient of variation speed? Do you see here? Do you see any plus minus, Angela?
No.
Yeah, then it means you take it the way it is, ne? I hope it's clear, ne? We double it when there is a change, when there is a plus minus, right? Hello, Andy.
Yeah.
Okay, let's solve this problem. Let's start by drawing. Let's move this up. Microsoft Whiteboard. Remember, we have talk and... Okay, let me start like this. Not head. Technology. Do you know Mr. Hong, Mr. Zahir, the guy that we had class with?
No.
We want our class together here.
I don't know him.
Oh, okay, but do you remember we had class together? No?
That time we were doing strength.
No, that time we were doing theory of machine, where we were doing the pulley, that guy.
I was not in that class.
Oh, I thought it was you. My video about the pulley, Newton meter. Okay, let's go. My phone is low, my laptop is low. Let me just look. Where is the plug here? I'm far away from the plug. Let me fetch my charger. Ooh la la la. Okay, it can actually reach here. That's a good thing. I do not have to move. Okay, thank you. Let's start. Remember, always make sure that these angles, they are in region, right?
Yeah.
Key first rule. Okay, they said, if you read the statement, they say that it's increasing. Do you see? Increasing uniformly from 0 to 300 during what? 45. Do you see it?
Yeah.
So this is 45 somewhere here. Remember I said we will work in region, so we can already convert this 45 degree in region. You multiply by pi, you divide by 180, you'll get pi over 4. Do it, you see? This is 0.0. Let me say this one is 300 Newton. When you do it, what do you get?
The 45.
Yes, in why is this thing not showing the rotation?
Pi over 4.
Okay, are you with me then? So this is what's happening. Can I just draw with free end?
Yeah, it's fine.
Okay, do you agree that this is pi over 4, right? Where these two matches. They said it goes from 0 to 300 over 45. So it means from 0 to 300, you have this line here. This is not nice. It's not looking good. You are not seeing what I want you to see. Okay, do you see that line, Andile? It means from 0 to 45, it goes here. This is where it meets. Do you see? That's what the problem says. And it says again that it remains constant during the next 45. What is the next 45, Andile? The next 45, it is simply 45 plus 45. What is 45 plus 45?
It's 90.
It's 90. So do you agree that 90 is somewhere here? Right? And what is 90? It's pi over 2 in radian. So when they say it remains constant, what does it mean, Andile? Ooh, what is this? What does it mean? When you reach here, there is a constant line here to here. This line is constant where there is 90. That's what it means. Are you with me?
Yeah.
And then they said, this guy, this Mr. Zaire, I think I'm calling him for 50 and it's bad. Now, they said decrease uniformly to 0 during the next 180. What is the next 180, Andile? The next 180 is simply 90 plus 180. What is that value?
It's 270.
270 is here. Do you agree? You don't have to be as accurate, but you can just show. So 370 is 3 pi over 2. Now what do? You can take the line and join this point to 270 here. Let me just do something like this that makes sense. Okay, do you see it?
Yeah.
And what are they saying again, Angela? They say that
someone is knocking. I'm coming.
Okay, fine, I'll wait for you. Mr. Zaire, nah, I wasn't calling you for the money. I was calling you to join the class. Can you join now if you can?
I'm back.
Where were we?
Sorry.
No, it's fine. It's okay.
Oh, we just did 180.
Okay. Now they say remaining 0 for the remainder of the revolution. What do you think is the remainder of the revolution? What is 316, eh? Yeah. Okay. Do you agree that this cycle here is made in a full revolution? Whatever happened here. Whatever happened here, it happened in the full revolution, which is what? 2 pi. Do you see?
Yeah.
360. Let's say in a problem, they say the problem is having 2 revolutions. What will be the value of theta? If 1 revolution is 2 pi, what is 2 revolution?
Revolution. I think it's.
Yeah, tell it. It has to be 4 pi.
I know. Yeah.
3 revolution is 6 pi. 4 revolution is 8 pi. Are you with me, Andy?
Yeah.
Now I'm just saying that because there are some problem where you don't have 1 revolution, you have 2, but I will make sure that we cover most of those problems. Okay, this is what's happening. What is the question asked here? The question that they asked here, Angela, they said, calculate the power delivered by the engine. You have this speed. What do we know about power? Okay, I said as we proceed, I'm gonna show you the formula that we'll be using according to what we have. In that case that we have, what is power? Here are the formula. Work done. Do you see this formula?
Yeah.
Work done is equal to mean torque multiplied by theta. Now, the work done is the area below the graph. Power is equal to mean torque multiplied by W. Let's write this formula. We know that work done is equal to mean torque multiplied by theta. I usually call it T mean. I don't like writing it TA, but I don't think it does matter. Now, what is next?
Power.
What is power again? They say there?
T mean multiplied by W.
Okay. What do you think is missing here, Andile? If we have to solve in this question, they want us to solve for power. What do you think we can get first here? Because if you look at this Formula 1 and Formula 2, for me to get power, what do I need? I need a mean torque, right?
Yeah.
But for me to get the mean torque, what do I need? I need the first formula. Do you see it?
Yeah.
Now, what is the work that they are talking about? If you see on the formula, the work that they are talking about here, it is simply area below the graph. So what is our graph? Our graph looks like this. It is a trapezoidal. Do you see it? What is the area below here? You can split this. You can call this one area 1. Do you see it?
Yeah.
This one area 2. This one what? Area 3. So it means if you get the area here, which is the work done, it is in joule, it will help us to get what? The mean torque. Do you agree?
Yeah.
And if you get the mean torque, we can get the power. This is how you deal with this case. Now, we have A1 plus A2. I need to do this, rest, and start you again. Plus A2 plus A3. Now, what is the area of a rectangular? It is half base times height. Am I making sense?
Yeah.
If you need to use this unit in red so that you don't have to convert. People that keep in radian and in degree and then convert at the end tends to forget. That's why in this topic, when I cheat it, I like it to convert already from the original. So, what is our first triangle? Do you see this one?
Yeah.
What is our base? Our base is 45, right?
Yeah.
Yeah, the base is 45 minus 0. So the base is pi over 4. Are we together? Half pi over 4 multiplied by height. What is the height, Angela? The height is 300. Do you see 300?
Yeah.
That is our height. You move to area 2. What is area 2? It is a rectangular, right?
Yeah.
It is base times breadth, length times breadth. I don't know what is. What is the base? You do 90 minus 45. It gives you this. Do you see it?
Yeah.
What is 90 minus 45? Or what is pi over 2 minus pi over 4? It gives you pi over 4. You can type to see to confirm.
Yeah, pi over 4.
So the base here is pi over 4. Remember, when you are solving for the base, you are making the difference between this and this. So what is the height? The height is what? 300 still. Plus, on the third triangle, it is half. What is the base? 270 minus 90. 3 pi over 2 minus pi over 2. What is that angle? I think it has to give 180.
It's pi over 2.
It is pi over 2, is 90. Yeah. So half base, pi over 2. What is the height? The height is also what? 300. Do you see it? Can you make this calculation and keep me the pi? Like, don't round it. If you calculate this, what do you get as answer?
Okay, let me see.
God will CD.
It's 589.
No, keep it with pi. What do you get?
Oh,
Don't, yeah, that's
one. Okay, 187
you
pi
get
over 2.
you get 187 for everything.
Pi over 2.
Okay, can we divide 187? Why do I feel like it's not right? On the textbook here, they are getting 262.5 pi. Let me try to calculate. Oh, at least this time I have my calculator. I'm having 150 pi.
150.
What is happening? We are supposed to have 262.5 pi. Half base times height. Plus base pi over 4 times height. Plus half base. Oh, I think I see my mistake. Pi over 2. Yes, I'm having 375 divided by 2 pi. What are you getting?
Still 187. What am I doing wrong?
Oh, we need 187 pi, ne?
Yeah, 187 pi over 2.
Me, I'm getting 187 pi. What is going on? On the textbook here, they are getting they are getting 262.5. What's happening? Half base times height. Let me check. Yeah, we need to have 185 like what do you get? Do you get 375 over 2?
No.
Angela, what do you get when you calculate?
I got 187 pi over 2.
187 pi over 2.
Yeah.
Okay, let's do this.
Okay, come on. Okay, now I understand. Yeah.
Yeah, this is what I'm getting as well, but the textbook is getting 262.5. What is happening? mosquitoes. Yes, okay, let's keep this answer like this then. Okay, if we have the work done, what can we find now? We can find the mean torque, right?
Yeah.
What is mean torque? It is work over what? Over theta.
All over it.
What is the theta? We take the theta for the revolution. What is that theta? For the
360.
it is 2 pi. So we're going to have 187.5 pi divided by 2 pi. So that the pi and pi cancel. What is the answer of the mean torque? Why are we not getting the same answers? What is happening here? What's the answer?
93.75.
That answer. Why are we not getting this, Andire?
I don't know.
Behaving this. Let's try again. It is half base times height. Half base pi over 4, height is 300, plus base times height, plus half base. What is 270 minus 90? Yeah, this is where the mistake is. 3 pi over
18.
What does it give? When you do 270 minus 90, or 3 pi over 2 minus pi over 2, it has to give pi.
It's pi.
Not pi over 2. That's why the mistake is. So can we redo this calculation? We need to find what's on the textbook. We need to find 262 comma. What do you get when you calculate? I heard that strength was easy. Was it?
So yeah, it's 262.
Now, if the pi cancel out, the answer of this guy, the mean torque, is 131.25 Newton meter. Are we together now? So what do you do when it is like that? You come here and you represent that value, which is 131.25, somewhere here on the graph. You draw your line as well. Where is the ruler? Where is the keeper? This is your mean torque. Are we together? You always solve for the mean torque in this case. Why? Remember, what did I say about the M here and delay? The M is to get what? Energy of fluctuation, right?
Yeah.
In this scenario, the energy of fluctuation, it is the area above the mean torque. This whole area. Everything here. This is what gives you your EF.
Okay.
Now we have solved for the torque. What is the second question? Even if without even knowing what is the question, you have to know that next what you follow is how to get your EF, right? The question here says, supposing that the engine drives rotate at this, calculate the mass of the flywheel if the radius of gyration is this, which is fitted in order the total variation of speed will be 1.5%. Now, what do we do? Let's solve EF before we answer even that one first, right? Remember, EF is our main priority. What is EF? Area above this one, right? Can I write it here? Do you see this, right?
Yeah.
Can I call it, since this one is area 1, can I try to name these ones on top here? You can call them a1 prime if you want, right?
Okay.
a2 prime and then a3 prime. So we know we're going to have a1 prime plus a2 prime plus a3 prime. Do you understand me the way I teach, Angela?
Yeah, I understand.
Oh, okay. Now, for a1 prime here, do you agree that we are on the small triangle here? This one, and this one, right? Let me try to highlight to see what is that triangle. Do you see it? But we don't know what is the base. That's why we call it x. We know this base, but we don't know this one. Do you agree?
Yeah.
So for a1 prime, you're going to have height. What is your base? X. Do you see it? But what is your height? Your height is the difference between what? 300 and what? 100.
1.
Yeah. Can we move to the second one, Angela, to a2 prime? What is a2 prime? It is rectangular. This one is not changing. This base is the same. Do you see it? The base down here is the same as this one. It's not being affected. Are you with me, Angela, on this one?
Yeah.
So we're going to have pi over 4. What is the height? Only the height is changing, which is 300 minus 131.25. Okay, we close. Plus, what is a3? a3 is this triangle here. Do you see it? We don't have the base, so we call it y. You can come and say half what? Y. Do you see?
Yeah.
To be 300 minus 13.25. As you can see here, what is avoiding us to solve for EF is simply this base here. But how do you solve it? I don't know how you guys call it in English, but in French we used to call it Thales theorem.
Pythagoras.
If I have x here, do you agree this is what I have, right?
Yeah.
I know that the distance from here to here is 300. Do you see it? The small distance here is the mean torque. It is 100. I don't know what is it. It is 131.2, right? Now, what else do I know? I know this is x. I know my base here. What is my base here? It is pi over 4, right? Anyway, let me just recall it in terms of a formula that can make sense. This is A, this is B. Do you see? This one is C, and this one here is D. Do you see? So we'll be doing a ratio here on the y-axis and also on the x-axis. We agree this is D. If I go C over D, do you see what I did? I went big over small. Do you see?
Okay.
So also on the other side here, I also have to go big over small. Now, to avoid a lot of math, let's do this. Let's change it. Let's start by what we're looking for, right? As we are looking for x, which is our A, right?
Yeah.
You can start with A over B, small over big, to be G over C. So, you see the ratio of small here over big here should be equal to small here over big. Do you see it?
Okay.
So can we apply it in our case here?
Okay.
We have half. Now we want to replace x. What is x? Okay, let me not jump to it quickly. Let's just try to solve x on its own. What are we going to have? We'll have x over. Do you see it?
Yeah.
To be equal to what?
313.
No, remember we went small over big. So we have to go small over big. So we have to go 131,26 over 300. Yeah, what am I doing? God. I think I'm missing something here. Yeah, I'm not missing anything. We said we go small over big. Yeah. No, what is the distance small here? Yeah. The distance small here, it has to be 300 minus this. I don't know if you see it. Do you see it?
Yeah.
Because 131 is the distance from here to here. If I want this height, it has to be 300 minus this. Do you see it?
Yeah.
So that small distance is 300 minus 131,26. So if you make x subject of the formula, which simply means x will be pi over 4 multiplied by everything here. Let me just call everything alpha. Don't do that in your test, please, man.
Okay.
I'm just showing you. I don't want to repeat the writing. The x that you're gonna be having here, yeah, them they keep it in degrees and you have to convert after. Okay, can you just calculate this? If you multiply pi over 4 by everything here, what do we have?
It's going to be 42.
You get what?
What is
You get pi over 4 multiplied by everything here.
pi over 4 multiplied by 300 minus 131.
Divide by.
Oh, okay. You want the full answer?
Yeah, just the answer. Yes, the full answer.
Okay. It's 0.44.
Oh, we get 0.44, right?
Yeah.
Okay, this is red. Now, can we do the same for y as well, and Angela? Remember, y, what is changing on y? Only the base is changing. Do you see it? The big base is 270 minus this. Do you see it? 270 minus 90 give us the big base, which is pi. Do you see it?
Yeah.
It is the same thing, only the base is changing. So what we're going to be having here is going to be y over pi. To be equal, this ratio will be the same. The biggest distance will also be 300 minus 131,26 over 300. So what is the answer of y in this case?
1,7 or 1,767.
1,767. Now that we do have this in radian, can we get EF, Andile? How can we get EF? You simply substitute x and y here and you get me the value of EF. Please substitute and tell me the answer, please.
Uh, 318.
Yeah, because they got also 318. We have 318 what? comma 9.
comma 91.
Yeah, 91 joule. Now, after finding EF, Angela, we can now come and answer this question. They said calculate the mass of the flywheel if the radius of gyration is this, which is fitted to the fluctuation speed of 1.5%. We are given Ks to be 1.5%. We are given the radius of gyration, K. What is radius of gyration again? 300 millimeter. Can I write it in meter 0.3? Okay, Angela, what do you know about radius of gyration? What is it? They said calculate the mass. Okay. What do we know? What is I when we have, what is moment of inertia when we have radius of gyration?
It's EF.
No, what is I? Moment of I. When you have radius of gyration, the formula moment of inertia is what? Mass multiplied by K square. We've seen this in mechanics 2, also in a previous chapter of theory of machine. Do you remember?
Yeah.
Now we know that this is the formula that we know. We know that Ks is equal to EF I W square. Do you see it? So if I'm asked to solve for the mass and I'm given radius of gyration, what do you think I should do? I can make I subject of the formula, ne?
Yeah.
Which will give EF over what? Over Ks multiplied by W square. Another thing that I can do, I can also replace I by what? Are you with me, Angela? So if I make mass subject of the formula, what will I have? I will have EF divided by K square. This is the radius of gyration. Multiplied by Ks. This is the coefficient of fluctuation speed. Multiplied by W square. So let's try to substitute M. What is E? E we find it to be 318,91 divided. What is K square? Radius of gyration is 0.3. So you have 0.3 square multiplied. What is Ks? What is Ks?
It's 0.015.
Yeah. Now, what is W? It should be given or provided in the question. W, they say it's what? The average speed is what? 600, right?
600. Yeah.
So you have here plus 600 times 2 pi over 6 everything squared. If you can solve for M, then you've got that mess. That's what's supposed to be there. I'm sure we're gonna get 59 as they got there. Any question, Angela?
No question.
Yeah, this is it. What else do we do? I think I'll have to rest until we meet next time. We do third case and then we can start solving all the problem.
Okay, no problem. Tomorrow same time?
Yeah, let's try tomorrow. Yeah. Sometime.
Okay, sharp.
Let me rest. Bye.
Bye.